Hello, this is the second page of exercises for section 5.5, the multiplication rule and the conditional probability. Suppose you are flipping a fair coin. What is the probability that you flip the coin twice and get heads on both flips? So, looking at a coin, the probability of getting a heads is going to be 1 out of 2 because one side of my two sides of my coin is a head, and the probability of getting a tails is going to be, again, 1 out of 2. So the probability that we flip a head and a head is going to be, again, we have this and, so we're going to do the multiplication rule. And then we got to think about if they're independent or dependent. So if I flip the coin on the first time, is it going to influence getting the head on the second flip? It's not going to. And so we're going to have independent. So probability of head times probability of head, which is 1/2 squared, which is 0.25. What is the probability that you flip the coin 3 times and get heads each time? So again, the probability of getting a head and getting another heads and getting another heads. Again, it's still a multiplication rule and it's still independent. So we're going to have probability of heads times probability of heads times probability of heads, which is going to be 1/2 cubed, which would be 0.125. So about 13% of the population is left-handed. If 2 people are randomly selected, what is the probability that both are left-handed? So we're going to assume that you can either be left-handed or right-handed. Left-handed is going to be 13% of the population. And then right-handed is going to be 1 minus 0.13. And this is going to give you 0.87. Okay, so probability that both are left-handed is probability that we have left and left. Again, we have an and, so we're going to have a multiplication rule. And then you got to think about if these are going to be independent events or not. So if you choose one person who's left-handed, is that going to influence the probability of choosing the next person who's left-handed? Since we are randomly selecting the individuals from the population, it's not going to affect it. So we'll have independent events here. So probability of left times probability of left, 3.13 squared, which is 0.0169. Okay. The probability that one is left-handed and one is right-handed. So we're choosing 2 people. I could have the first person being left and the second person being right, or you have the first person being right and the second person being left-handed. So this probability is probability that we are left then right, or we're having right then left. Okay, so this is a kind of a compound inequality, compound probability that has both multiplication and addition in it. This is an and, as is this one. So this is going to be an and probability because we have left and right, or right and left. There's going to be multiplication, and they're independent. Okay, this or, it's going to make us do the addition rule. And we have to think about, can you simultaneously be this event and this event? You can't, so they're going to be disjoint. Okay, so probability that we're going to have left then and then right, plus probability we're going to have right and then left. Okay, so again, this is multiplication, so there's going to be multiplication of these two probabilities. So probability of left times probability of right plus probability of right times probability of left. So I have 0.13 times 0.87 plus 0.13 times 0.87 times 0.13, which you know is the same thing. Both of these are adding the same thing together. And when you add them together, you get 0.2262. Okay? So the probability that at least one is right-handed is a probability that at least one is right-handed is, using the formula, 1 minus probability that none of the two is right-handed. Okay? So again, we've got to think about what it means to be none is right-handed. And that's going to be that both are left-handed. And both are left-handed. It's actually what we figured out here in part A. So it's going to be 1 minus 0.0169 from part A work. And that will give us 0.9831. On a multiple choice quiz with 4 possible choices for each question, a student answers all 4 questions by making random guesses. So that means that on each question, the probability of them being right is going to be 1 out of 4, because we have 1 that's right out of 4 choices. And the probability that we are wrong is going to be 3 out of 4, because there's 3 wrong choices out of your 4 choices. Okay, it's probably that all 4 are correct. That's the same thing as being right, and right, and right, and right. Okay, so we have and, so we have the multiplication rule. And then if you're right on the first question, is that going to influence you being right on the second question? It's not going to. Okay, so they're independent. So this is going to be 1/4 times 1/4 times 1/4 times 1/4, or 1/4 to the 4th power, which is 0.0039. And the probability that all 4 answers are wrong. That's going to be probability of being wrong, and wrong, and wrong, and wrong. Again, we have the and probability, so we're going to have multiplication. And being wrong on one problem won't influence whether you're wrong on the next problem, so they're going to be independent. And so it's going to be probability of wrong times probability of wrong times probability of wrong times probability of wrong, so it's going to be 3/4 to the 4th power, which will be 0.3164. All right, so let's find the probability that at least one is correct. So the probability that at least one is correct. Okay, that's going to be 1 minus the probability that none are correct. Okay, and this is out of 4 answers, right? This is 4 answers that we have. Okay, so this is 4 questions here. So again, highlight that this event being correct is going to be, so at least one of that event is 1 minus probability of none of that event. Okay, so that's the same thing as 1 time minus probability that all are wrong. And all being wrong is what we figured out in part B. So 1 minus 0.31 0.64. And when you find that out, you'll get this answer as being 0.6836. Okay. So this last question is, find the probability that 1 is wrong and 3 are correct. The order is not specified. So we have 4 questions here. We could be wrong on the first one and be right on the last 3 questions. We could be right on the first one, wrong on the second one, right on the third and fourth one. We could be right on the first one, right on the second one, wrong on the first one, the third one, and right on the fourth one. Or we could be right for the first 3 and then wrong on the last one. This would be 1 is wrong and 3 are correct. Okay, so here it's similar to what we did above. We have the probability of wrong, right, 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 or right, wrong, right, right, or right, right, wrong, right, or right, 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 wrong. Okay, so within these groupings, these are and probabilities that are going to be independent. So we're going to multiply in this and probability, this and probability, this and probability, or this and probability. But then we have ors, so we have to use the addition rule between them. And these are disjoint events. So we're going to add this probability to this probability to this probability to this probability. Okay, so we're going to have being wrong is going to be 3/4, and then we're going to have 3 right, so we're going to have 1/4 cubed. And then we're going to add that to the next one. So I'm going to have 1 that's right, so it's going to be 1/4 times 1 wrong times 2 that are going to be right. Here we're going to have 2 that are wrong. 2 that are right, sorry. Times 1 that is wrong. Times 1 that is right. And then here I'm going to have 3 that are right. Again, R means right. We're going to have 3 that are right and 1 that is wrong. Okay, and if you look at this, even though you can see really easily that this first term and this last term are the same, okay, but even these middle terms are the same, I just ended up not multiplying all the 1/4 together to have it 1/4 cubed. Okay, so this is really 4 times 1/4 cubed times 3/4. And when you do that, you get the answer of 0.0469.